Because the principles used are very similar to our light switch exercise, we will in this video see how we can use the line trace node in a construction script to help us figure out an actor's location in the world. Inside the content browser then, after making sure that we are in the ceiling light folder, let's double click the blueprint actor of the same name so that we can see its construction script, which can be accessed via a double click inside the functions rollout of the My Blueprints tab if needed. As already noted, we want the script to affect this actor each and every time it is dragged into the 3D view. And so, adding the logic inside the construction script makes sense, as this will execute when we are working with the actor in the 3D view, and not just at runtime. Now that we are inside the correct graph for our actor, we will want to drag a reference of the scene root onto the graph. As transform information is stored in the actor's root, and because we know in this case the root is sitting at world 0 in terms of the x, y, and z coordinates, the scene root is the perfect point from which to test our object's location. In fact, rather than take my word for it, let's click the Viewport tab so as to see our static mesh, and then take a look at its relation to the scene root. Now, because this is meant to be a ceiling light, the static mesh component is actually sitting below the 3D viewport's grid here, thus ensuring that the scene root is always at the top of the light object, which is right where we will want it to snap to should any ceiling geometry be sitting above it. Now that we have seen how the mesh and root are placed then, we can come back to the construction script, drag out from the scene root reference, and then type get world into the search field, clicking to add the get world location node to the graph once it appears. We have already seen this tool in action back when we created the line trace for our light switch camera, only this time around we are wanting it to grab the location of the ceiling light's root. With the node in place, and after right-clicking in some empty space in the graph, let's type get actor up into the search field, and then click to add the get actor up vector, after which we can drag from its output, and this time search for the vector times float node, adding that to the graph as well. We want the up vector of this actor for obvious reasons, given that we need a direction in which to shoot our line trace ray. This being a ceiling light object, of course, then the direction will always be up, although we can use any axis that we want, and so if we needed to create a light that snaps to a wall, for example, then we could set up using the appropriate axis here. We have also added the vector times float node in order to set the maximum distance that our blueprint actor will search above itself in order to see if it should be snapping to any geometry. Although this may take a little trial and error depending on the scale and size of the rooms in your own particular projects, we can happily go ahead and set the B float value to 100 in this instance. This should stop the light snapping to just any old ceiling in the scene the instant we drag it into the 3D view, giving us time to move it around and perhaps get a bit closer to the intended target before Unreal takes over and snaps it into position. If this is too small or too big a value in your opinion, please feel free to experiment until you have set a distance that you like. Okay, time to do some math now, so as to be sure that we have correct values that can then be plugged into the line trace node that we will create a little later on. Coming to the get world location node then, we can drag from its output, and after releasing the mouse button, type plus into the search field, and then add the vector plus vector node that appears, making sure that the output from the vector plus float node is piped into its B input. As our line trace node needs a start and end input using transform or x, y, and z values, we want it to shoot upward in a straight line. We need the x and y values to be the same for the start and end points. Then add the distance of 100 to the z value of the end transform. This is why we are having to perform this little bit of math calculation. We have already seen this same principle in action, of course, but what we can take note of here is that it is possible to take the same basic blueprint setup and then use it in a very different situation and put it to a seemingly completely different use. Now that we know how to set both the start and end locations for a line trace in a blueprint that will be placed in our level, we are of course well on our way to having the end result that we want.